Hey everyone, welcome back to the channel. So here's the situation. Right now, as I'm recording this on October 17th, 2025, there's an object racing through our solar system that's got the entire astronomical community in an absolute frenzy. We're talking about something that's traveled from another star system, something that weighs 33 billion tons, something that's 1,000 times more massive than the famous Oumuamua, and something that's behaving so strangely that one of the world's top astrophysicists published a paper seriously asking if it might be alien technology. Not kidding. Not exaggerating. That's literally what's happening right now. I'm talking about 3i Atlas, and this story is absolutely wild. So stick around, because by the end of this video, you're going to understand why scientists are having heated arguments in academic journals, why the timing of this discovery is almost too perfect, and why the next 12 days could completely change our understanding of what's possible in the universe. But real quick before we dive in, I need to be completely transparent with you about something. Creating content like this, where I'm digging through actual research papers, cross checking data from multiple observatories, and making sure every fact I give you is accurate and up to date, that takes work. And more specifically, it takes resources. I use AI tools to help process huge amounts of scientific data, to scan through preprint servers like AR-14, to analyze spectroscopy reports, and to make sure I'm not missing critical details. Those tools cost money, real money, every video. So if you appreciate this kind of in-depth coverage, if you value having someone translate dense astrophysics into plain English without dumbing it down, please take 2 seconds to hit that like button and subscribe to the channel. Seriously, it makes a massive difference. Your support is what allows me to keep doing this, to keep bringing you cutting edge space news as it's happening. All right, let's get into it. So, July 1st, 2025. The Atlas Survey Telescope in Hawaii picks up a new object moving through space. At first glance, it looks like it might be a comet or maybe an asteroid, but something immediately stands out. The velocity is wrong. Way wrong. This thing is moving at 59.7 kilometers per second relative to our sun. That's over 130,000 miles per hour. You could circumnavigate the entire Earth in about 20 minutes at that speed. But here's the kicker. When astronomers calculated the orbital eccentricity, they got a number that made everyone stop what they were doing. 6.1, maybe 6.2, depending on which measurements you use. And if you know anything about orbital mechanics, you know that anything above 1.0 means the object isn't captured by the sun's gravity. It's not orbiting, it's passing through. This is an interstellar visitor. Now, we've seen this twice before. Oumuamua in 2017 blew everyone's minds because it was the first confirmed interstellar object we'd ever detected. Then Borisov in 2019 was kind of a relief because it acted exactly like a normal comet, just from another star system. But 3A Atlas? This one's different. This one's throwing curveballs left and right. And the first curveball is the sheer size of this thing. In September 2025, scientists compiled observations from Hubble and ground-based telescopes and did the math. The nucleus of 3I Atlas is somewhere between 3.1 and 4.6 miles in diameter. That's 5 to 7 kilometers. For perspective, that's roughly the size of Mount Everest from base to peak. And it weighs over 33 billion tons. Avi Loeb from Harvard crunched the numbers and pointed out that 3i Atlas is between 1,000 and 100,000 times more massive than Oumuamua. Think about that for a second. When we discovered Oumuamua, we thought we'd gotten lucky catching a relatively small interstellar object. Now we're looking at something that dwarfs it by 3 to 5 orders of magnitude. It's like thinking you've caught a minnow and then realizing there's a whale swimming right behind it. And here's what's weird. An object this big should have been detected much earlier. The fact that we didn't spot it until July, when it was already relatively close to us in astronomical terms, suggests it's either unusually dark or it's made of material that doesn't reflect sunlight the way we'd expect. Right away, that's anomaly number one. Then in early October, NASA's Swift Observatory, which usually spends its time hunting gamma ray bursts and studying high energy cosmic events, turned its attention to 3i Atlas. And what they found was genuinely shocking. Water. specifically hydroxyl emissions, which is the chemical fingerprint of water molecules breaking apart. They detected this when 3I Atlas was still about 3 astronomical units from the Sun. That's roughly 450 million kilometers, or about 3 times the distance from Earth to the Sun. Now, here's why that's a problem. Comets are basically dirty snowballs. They're made of ice, rock, and organic compounds all frozen together. When they get close to the sun, the ice heats up, sublimates directly from solid to gas, and that creates the classic tail. But this process doesn't really kick off until a comet crosses the frost line, which is somewhere around Mars's orbit. Before that, comets are supposed to be dormant, frozen, inactive. 3i Atlas said, nah, I'm gonna do my own thing, and started spewing water way earlier than it should. The team from Auburn University that published this finding described it as leaking water like a fire hydrant running full blast. They measured the rate at 40 kilograms per second. That's 88 pounds of water blasting into space every single second. At that rate, you could fill an Olympic swimming pool in about a month and a half. And this is happening at a distance where it shouldn't be happening at all. So either the internal structure of this comet is radically different from anything we've seen, maybe it's got fractures or voids that allow heat to penetrate deep inside, or the composition is so exotic that our models just don't apply. But the chemical weirdness doesn't stop there. In late August, astronomers using the Keck telescope in Hawaii captured spectroscopic data that revealed something I honestly had to read 3 times to believe. 3I Atlas is emitting nickel, atomic nickel. Now, nickel isn't completely unheard of in comets. We detected it before. But here's the thing. In every single comet we've ever studied, nickel and iron show up together. They're chemically linked. They form together in stars. They condense together in planetary systems. They're like peanut butter and jelly. Except 3I Atlas has nickel but no iron. None. And there's only one place we've ever seen nickel without iron. Industrial nickel refinement here on Earth using a process called the Mond process, where you create and then decompose nickel tetracarbonyl. It's a human technology. Now, the scientists who made this discovery are very careful to say that there could be a natural explanation. Maybe there's some exotic chemical fractionation process happening near the nucleus that we don't understand yet. Maybe the stellar environment where this comet formed had unusual metallicity ratios. But the fact that it even remotely resembles an industrial process, that got people's attention. And it's not just Avi Loeb making this connection. Multiple researchers have commented on how unusual this nickel without iron situation is. The Keck data also shows cyanide, yes, cyanide, extending out about 840 kilometers from the nucleus, along with that nickel reaching about 600 kilometers. The total mass loss rate is around 150 kilograms per second, which is high. Really high for an object that's still this far from the sun. And then there's the James Webb data from earlier this year showing that 3I Atlas has an inverted composition compared to typical comets. It's 87% carbon dioxide, 9% carbon monoxide, and only 4% water. Most solar system comets are the opposite. They're water dominated with some CO2 mixed in. This thing is backwards. It's like finding a fish that breathes air and walks on land. Technically possible, but weird enough to make you question your assumptions about how fish work. And all of these chemical anomalies are happening while the object is still relatively far from peak heating. We haven't even gotten to perihelion yet, the point of maximum solar intensity, which happens on October 29th, just 12 days from now. Now let's talk about the tail situation, because this is where things go from weird to borderline absurd. Comet tails form because of solar wind and radiation pressure. The sun is constantly blasting out particles and light, and that pushes material away from the comet's nucleus. The result is a tail that always points away from the sun. Always. It's one of the most basic, fundamental aspects of comet behavior. You could teach this to a middle schooler. Tail points away from Sunday Simple. Except 3I Atlas apparently didn't get the memo. Observations in mid-October confirmed that it's developed an anti-solar tail, a structure pointing toward the sun, not away from it, toward it. Now, some astronomers have suggested this might be a viewing geometry effect, what's called a neckline structure, where the angle we're observing from makes dust particles appear to point sunward even though they're really in the orbital plane. But that doesn't fully explain the gas emissions. The spectroscopy shows actual molecular emissions extending in both directions, solar and antisolar. It's not just dust. It's not just an optical illusion. There's something genuinely strange happening with the outgassing dynamics. And on top of that, there's no visible dust tail in white light images. Most comets have a bright, obvious dust tail because sunlight bounces off the particles. 3i Atlas? Just gas. Just these bizarre chemical plumes going in directions they shouldn't. It's breaking the rules, and nobody has a complete explanation yet. So let's summarize what we've got so far. Interstellar object. Check. 1,000 times more massive than Oumuamua. Check. Leaking water way too early. Check. Nickel without iron resembling industrial processes. Check. Inverted chemical composition. Check. Backwards tail. Check. And it passed within 30 million kilometers of Mars in early October, where ESA's spacecraft managed to capture images, though we're still waiting on the high-resolution shots from NASA's Mars Reconnaissance Orbiter. That's a lot of weirdness packed into one object. And when you have that many anomalies stacking up, you start to see two camps forming in the scientific community. Camp 1 says, it's just a really unusual comet from a different stellar environment, and we need to be patient while we figure out the details. Camp 2 says, hold on, this is weird enough that we should seriously consider alternative explanations. Enter Avi Abraham Loeb, professor at Harvard, founder of the Galileo Project, and probably the most controversial figure in modern astronomy. In July 2025, Loeb and his collaborators published a paper titled, Is the Interstellar Object 3i Atlas Alien Technology? And look, I know what you're thinking. That sounds like clickbait. That sounds like sensationalism designed to get headlines. But here's the thing. Loeb is a serious scientist. He's published over 1,000 papers, many of them in top-tier journals. He's not some fringe figure making wild claims without evidence. He's doing actual calculations, running actual numbers, and presenting a hypothesis based on data. You can disagree with his conclusions, many scientists do, but you can't dismiss him as a crank. So, what's his argument? First, the trajectory. 3i Atlas has passed unusually close to three major planets Mars, Venus, and Jupiter. Loeb calculated the probability of a random object happening to pass that close to all three purely by chance. The result? 0.005%. 5 in 100,000. Now, does improbable mean impossible? No. Improbable things happen. If you shuffle a deck of cards, the specific order you get has a probability of 1 in 10 to the power of 68, but it still happens. But when you start stacking improbabilities on top of each other, at some point you have to ask whether chance is really the best explanation. Loeb also points out that the trajectory of 3i Atlas is consistent with what you'd expect from a probe performing a solar oberth maneuver. That's a technique where you use the sun's gravity to change your velocity without burning fuel. If you're an interstellar probe trying to slow down and explore a new star system, that's exactly the kind of maneuver you'd perform. Is that proof? No. Is it consistent with artificial origin? Yes. Loeb gives 3i Atlas a 30 to 40% probability of being non-natural. Not 90%. Not 50-50. 30 to 40. That's a measured, cautious estimate that says, I don't know for sure, but this deserves investigation. He's even invoked the dark forest hypothesis, a concept from science fiction suggesting that advanced civilizations might disguise their technology to avoid detection. The idea is that if the universe is full of potentially hostile civilizations, you wouldn't want to announce your presence with obviously artificial technology. You'd make your probes look like natural objects, comets, asteroids, things that wouldn't trigger alarm bells. Now, is that what 3i Atlas is? Who knows? But it's an interesting thought experiment, and it highlights why Loeb thinks we should take the artificial hypothesis seriously. On the other side of this debate, we have the SETI Institute, which published a rebuttal paper in October titled Updated Trajectory and Spectral Insights into 3i Atlas, a definitive case for natural astrogeological origins. This paper is basically a point by point takedown of the alien hypothesis. The authors argue that every single anomaly can be explained by natural processes if you're willing to dig into the details. Early water activity, unusual internal structure, nickel without iron, chemical fractionation in a different stellar environment, antisolar tail, complex gas dynamics combined with viewing geometry. The paper emphasizes that weird does not equal artificial, and that jumping to the alien explanation before exhausting natural possibilities is bad science. They point to Borisov as an example. When we first discovered it, it also had some unusual characteristics: different composition than solar system comets, higher velocities than expected. But it turned out to be completely natural, just formed in a different chemical environment. The SETI authors argue that 3I Atlas is the same situation, just more extreme. And they make a good point. The universe is under no obligation to make sense to us immediately. Sometimes nature is just weird, and we need to update our models instead of jumping to extraordinary conclusions. So who's right? Well, that's the $64,000 question, isn't it? And the honest answer is we don't know yet. Both sides have legitimate arguments. Loeb is right that the statistical clustering of anomalies is suspicious and worth investigating without prejudice. The SETI team is right that extraordinary claims require extraordinary evidence, and we don't have smoking gun proof of artificiality. What we have is a puzzle, a really complex, multi layered puzzle that's going to take time and more data to solve. Michio Kaku, the theoretical physicist and science communicator, has weighed in on this as well, and his perspective is characteristically balanced. He's pointed out that we're in an era where the search for extraterrestrial intelligence and extraterrestrial technology is no longer fringe science. It's mainstream. With thousands of exoplanets discovered, many inhabitable zones, and with our technology advancing to the point where we could detect technosignatures across interstellar distances, the possibility of encountering alien artifacts is statistically real. Not guaranteed, but real. Kaku has called 3I Atlas a wild card, something that doesn't fit our existing categories and therefore demands rigorous investigation without preconceptions. Follow the data. Don't assume it's aliens, but don't assume it's not either. Just follow the data. And we're about to get a lot more data. 3I Atlas reaches perihelion on October 29th, just 12 days away. That's when it'll be closest to the sun, experiencing maximum heating, maximum outgassing, maximum activity. Whatever this thing is, we're about to see it at full intensity. The problem is, Earth and 3I Atlas will be on opposite sides of the sun during perihelion, which means we can't observe it directly from here. It'll be hidden in the sun's glare. But Mars has a perfect view, and the spacecraft orbiting Mars are locked and loaded. ESA's ExoMars Trace Gas Orbiter, Mars Express, and NASA's Mars Reconnaissance Orbiter are all planning observations. We'll be watching from Mars while Earth is blocked out. How amazing is that? After perihelion, 3I Atlas will be visible from Earth again in early November. It'll be fading as it heads back out into interstellar space, but we'll have another window. ESA's JUICE mission is planning observations. NASA's Juno spacecraft will image it in March 2026. And the Vera C. Rubin Observatory, when it comes fully online, is expected to find dozens or maybe hundreds more interstellar objects in the coming years. Right now, we're working with a sample size of 3. That's not enough to understand what's normal for interstellar visitors. But as the sample grows, patterns will emerge. We'll learn whether 3I Atlas is genuinely anomalous or just the first example of a whole class of objects we didn't know existed. Let's talk about the age of this thing, because that adds another layer of mind-bending perspective. Studies published in July 2025 analyzed the kinematics of 3I Atlas, its motion through the galaxy, and compared it to the age-velocity dispersion relation of stars in the Milky Way. Older objects tend to have higher random velocities because they've been gravitationally perturbed over billions of years. Based on this analysis, 3I Atlas is estimated to be between 3 and 14 billion years old, with the most likely range being 7 to 10 billion years. Let me put that in perspective. Our solar system formed 4.6 billion years ago. 3I Atlas might be twice that age. It could have formed in the early Milky Way, when the galaxy was still assembling, when the first generations of massive stars were enriching the interstellar medium with heavy elements. It's a relic, a time capsule from an earlier era of cosmic history. The kinematic data suggests it belongs to either the thin disk or thick disk population of the galaxy. The thick disk contains older, metal poor stars that formed when the galaxy was younger. The fact that 3I Atlas has a high vertical velocity component, meaning it's moving perpendicular to the galactic plane rather than just orbiting smoothly, supports an older age. This thing has been wandering through interstellar space for potentially 10 billion years, completely isolated, exposed to cosmic rays and interstellar erosion, and it survived. And now, by pure chance, its path intersected ours at exactly the moment we have the technology to study it. That's either an incredible coincidence or, if you're Avi Loeb, suspiciously perfect timing. Whether 3i Atlas is natural or artificial, and I personally lean toward natural because that's the simpler explanation. It's teaching us something profound. If it's natural, it's showing us that planetary systems around other stars can produce chemical environments wildly different from our own, which has huge implications for understanding planetary formation, stellar evolution, and the diversity of cosmic chemistry. Every star system is a unique laboratory, and 3i Atlas is our window into one we'll never visit. If it's artificial, well, that changes everything. That means intelligence exists elsewhere, that civilizations build and send probes, that we're not alone. Either way, we learned something incredible. So here's the bottom line: 3i Atlas is real, it's massive, it's weird, and it's happening right now. Scientists are divided, and that's good. That's how science works. You debate, you gather data, you test hypotheses, you refine your understanding. We're about to get a flood of new data in the next few weeks as this thing hits perihelion, and that data will help us answer some of these questions. Whether you think it's a bizarre comet or an alien probe, this is one of the most exciting astronomical events of the decade, and you're here for it. Before I wrap up, seriously, if you found this valuable, if you learned something new, hit that like button and subscribe. It helps more than you know. Drop a comment and tell me what you think. Is this just a weird comet from a different stellar environment, or is Avi Loeb onto something? I want to hear your take. And as always, keep looking up, keep questioning, and keep being curious. The universe is full of mysteries, and we're living in the golden age of discovery. Thanks for watching, and I'll see you in the next one with hopefully even more data on this cosmic enigma. Stay curious, space enthusiasts. The cosmos never stops surprising us.